Hey everyone, I think we can start. If I hope the slides are showing, just checking them up. Okay, seems to be good. Please write on ERC if it isn't. Okay, this. Okay. Okay, so let's start. This is a deep dive for oVirt 3.6. I'm going to present the new 3.6 feature, guest serial console access. I am Francesco Romani, I'm software engineer, and I work indeed for the oVirt project. So, So, serial console. This is an old serial console. Nowadays things are a bit different, and they looks looks different. But why, in the first place, one administrator or one user want to use serial console? Mostly, not exclusively, for administration purposes. It is easier. Nowadays, it's not really much different from a user perspective, from plain SSH access, and it looks like this. For example, this is access through console using Virsh, which is the libvirt administration tool. Nowadays, consoles are already available through oVirt. They are presented and configured like any other device. And they need to be configured per VM, like we can see here. Here I'm showing a clipped screenshot of the oVirt engine web admin. Here we can see the edit virtual machine pane and the highlighted checkbox. It is the one which indeed enable the virt.io console device itself. It is disabled by default. Once this is enabled, it is accessible using Virsh, like I shown before. Up until and including oVirt 3.5, how can one administrator or one user access Virsh, a VM console? There are a lot of ways, but probably the most common is just locate the VM, SSH to the host which is running the VM, somehow map the VM from the identifier oVirt uses to the low-level one libvirt using, and once everything is done, one can just use Virsh console and attach one pseudo terminal to the console. The one thing noteworthy is that VDSM imposes password authentication, which is not meant as a security measure. So one must take care of this authentication before to connect. In oVirt 3.6, it is simple, like a plain SSH connection, like this. One has just to connect to the proxy using a few parameters, and that's it, because the new feature takes care of all the bookkeeping. So block diagram is something like this. We have a new package, which is oVirt VM console, which indeed takes care of all the automation to connect to the console, which is configured it is made building on SSHD and a few configuration hooks. So, for example, like we'll discuss later, authorized user command, and the oVirt VM console is integrated to the oVirt engine to fetch, for example, the VM positioning information where a VM is running. So the user it is automatically routed to the right VM hypervisor host. Also, the authentication keys are the basic authentication mechanism. So the security is ensured this way, and these keys are stored in the oVirt engine using the engine facilities. How it will look? We will have generic oVirt VM console package split in two main packages plus one which is generic. The oVirt VM console proxies, they say the user-facing service the users will connect to, and they will just have this endpoint and nothing else. But for management purposes, the oVirt VM console host must be installed on each host on which will run VMs, and this is needed by the system, but it is also automatically installed by the oVirt host deploy. oVirt engine will store also the authentication keys, as I said, and the integration between the two packages, the oVirt VM console and the oVirt engine, is automatically done by the oVirt engine setup, which takes care to set up the oVirt VM console helper, which we'll see in a few moments, and which will feed the oVirt VM console with the data it needs for, like, again, the authorization keys and the console availability. Because when one user connects, the system must know which console the user can connect to. So the oVirt VM console proxy overview. As I said, we have one custom SSHD instance, which with custom I mean special configuration, and also of course we don't hijack any SSHD which can be already installed. So we just use a different instance. SSHD though make guarantees, of course, about authentication and security, so the channel is safe. And indeed, we have integration points. We have extra tools to retrieve the keys, because they will be automatically managed by engine, and of course to fetch the information from engine and to feed it into the VM console package. oVirt engine was enhanced to be able to store the SSH key, of course, per user. So each user can have so far one SSH key to be used to connect to VMs. And in the future, we will have probably more keys, but for now, it's just one of them. Once the user is authenticated, the system must provide a list of consoles on which the user can connect to, or the user can specify directly a console to connect to. So the oVirt VM console needs to validate or to have actually this list, to validate this console against the whitelist, or to present this list to the user. To do so, it just asks through another helper, which is oVirt VM console proxy shell. It asks indirectly. It asks the engine about the console, the available console for a given user. Okay, now let's start to dig a bit in more details about how the system works, starting with the storage of the keys, because we decided to store the authorized keys in the engine itself to ease the management. And this is managed by engine again, and this is made using a facility which was added to SSHD, which is authorized user command, which replaces the authorized keys file. We will have more details later on. So let's see. I will skip the detailed description, and I will just describe it starting from this diagram. Hopefully it's clearer. This is the first step, how the system authenticates a user which wants to connect. As I said, this is done using the authorized keys command, which, I remember correctly, was added. Okay, it was added a few releases ago. It is available. It is widespread. So from high-level perspective, we can see the flow following the numbers near to the arrows. When user connects using to the special purpose SSH daemon, the daemon is configured again to spawn this custom command to fetch this list of keys, which this tool must provide an output which is exactly the same as one can write in the authorized keys, so exactly the same syntax. This tool is provided by oVirt VM console. It is oVirt VM console proxy keys. So the oVirt VM console proxy keys is agnostic with respect to oVirt engine. So it is configured to delegate the task to actually fetch the keys to oVirt VM console list, which is an helper provided by the engine. It is a package which can be installed. This helper tool asks engine for the keys through it sends a ticket using a service API. The engine fetches the data, retrieves back. Once back, we go to the oVirt VM console, back to oVirt console list, and it returns the data in JSON format to the oVirt VM console proxy keys package. And once this data is available, the proxy keys reformats it in the format SSHD is expecting. Once that is done, the normal flow of authentication inside the SSHD can go ahead, and so the key is validated or not. And so far it is just an extension point to the normal key-based authentication flows. So this step is secured. Once that is done, the user is authenticated, and once again, the SSHD is configured to run exactly one command, which is the other helper, which oVirt VM console package is shipping, which is oVirt VM console proxy shell. We will see that in a moment. Again, we have the flow. I just described the measure points, which I'm going to describe. So let's go forward to the diagram. The slides I'm showing, they have notes and reminders about the meaning of numbers, and the slides will be available on the oVirt wiki later on. So the user is authenticated. From now on, SSG spawns the helper, which is oVirt VM console proxy shell. Now we have two cases. Either the user has not specified a specific console using an ID which he wants to connect, or he has already, for example, connected to a console. He remembers or she remembers the ID, so he or she provided the ID. Either way, the oVirt VM console proxy shell needs validate this console and make sure the user can legitimately connect to this console. So we need the list of available console per user. And again, this task is easily fulfilled by oVirt engine. And once again, the oVirt VM console proxy shell is generic, so it doesn't know in itself how to get this list, but it is configured again by oVirt engine staff to delegate this task to fetch the available console to another script, which is the same as before, which is parametric. So the oVirt VM console proxy shell uses this helper to fetch the list of available console per user from engine. Again, the exchange happens securely using a ticket. And this data is returned by the helper in JSON format, and the proxy shell does the checks it needs to be done. And if the user is allowed to connect to a console, then the process can go ahead. On the other hand, if the user has not specified the console which he or she wants to connect, then it is, of course, the data returned back by engine is used to provide an interactive list of console to be selected to connect to. And of course, the user is allowed to connect to any of these consoles. Once that is done, we are almost done, because from now on we were only on the proxy host, but because again this is the only host the user should care of connecting into. But the console, the VM, is actually running elsewhere on one hypervisor host inside the data center. So we need to jump on that host. To jump on that host, we will use some data which is returned by engine in this very step. For example, in step 15, among the other information, the oVirt VM console list helper returns the position in the form of the address of the VM console. I'm sorry, of the VM on which the admin wants to connect. And this way, the oVirt VM console proxy shell can prepare all the configuration it needs to spawn another SSH instance, which is transparently connected to the user's SSH. So it is bridged. All the needed keys, for example, the key-based authentication and the configuration, is automatically set up on the fly by oVirt VM console proxy shell. But the keys needed to connect from the proxy to the various hosts is performed by oVirt host deploy. But once again, when the user connects, everything is already set up. So when we jump from the proxy to the host, everything is either configured on the fly if needed, or already there, for example, the keys. So once everything is ready, we can jump to the final destination using another SSH connection. And on the last mile, so-called last mile, so on the actual hypervisor host on which the VM is running, we need to make one last hop to actually connect the initial SSH process the user started back in time to the console. Again, in this slide, we have an overview, and here we have a diagram. I'm going to just describe the major steps on this diagram. As I said a few slides before, on each hypervisor host, a new service is installed, which is the oVirt VM console host. Like oVirt VM console proxy, this service is using another custom SSHD instance, specially configured, and this service allows exactly one command when one user connects from on this service, which is oVirt VM console host shell. So the only action which can be done when someone connects is to actually connect to this shell. When a connection happens, the oVirt VM console host shell is executed, and the console ID is passed. The oVirt VM console host shell receives this console ID, which of course is related to the VM ID. From this ID, the tool can detect and create a Unix socket domain path, and it can spawn a socket instance to finally connect the channel from the user to the VM console. Here we can see indeed that previously the console were configured using to be bound. The VM console were configured to be bound to PTY. This is actually the mechanism oVirt is using. It uses a PTY. Now the VDSM configures the VM through libvirt to be bound to Unix domain socket, indeed, to make all these mechanisms work. So if for some reason an admin needs to connect manually, oVirt will not be working anymore. But considering the permission, the file system permission, one can just connect itself on its own using socket or beacon or anything else to the very same VM console socket. So this is the last link here, and it is also the easier link, because basically it boils down to one socket to build the right path for the Unix socket and spawn socket. So on the host side, it is pretty simple. On the proxy side, it is a bit more complicated. This diagram summarizes all the steps. Once again, the meaning of the funny numbers and arrows are described in the notes. They are exactly the same like in the previous slides. This approach works, but there are a few limitations still for the current implementation. First one is that on migration, the link will be lost. This is an open point. There are ideas how to deal with that, but so far one has to expect disconnection in case of migrations. Another noteworthy limitation is for lack of setup reasons, meaning that engine setups has some assumptions. The proxy host is expected to be run on the same host on which engine is running. Again, there are no limitation on proxy itself, meaning all the scripts and helpers and components I mentioned and I described can work if engine is on another host, but the automated setup cannot yet properly configure things if engine is on a different host. This will be addressed in the future. And for the establishing the connection, the proxy depends on engine, meaning that if engine is unreachable, the console, the user cannot connect to the consoles using this mechanism, this new mechanism as I described, for a couple of obvious reasons, because the engine is, of course, required to fetch the keys and the VM positioning. And if a connection is established and engine goes down or becomes unreachable, it is expected to have no impact on the current established connection. Of course, there are limitations we acknowledge and we will address in the future releases. It mostly boils down to first thing to allow a setup to be smarter and set up and indeed set up, no pun intended, the things on when proxy is running on a different host. And that's almost it. I would like to show how it looks like using a screenshot. I thought it will be useful to have some kind of video demo, live demo, but in the end, from the user perspective, it is really like a plain SSH connection. So, I mean, if we don't want to be under the hood, like describing all the moving parts I did and exploring the details of how setup works and how the pieces interact, it really is simple like an SSH connection. So I think that's it. There is plenty of time for questions if there are any. Please share your question on the IRC on oVirt channel. Otherwise, I think that's it. A few more times. Questions? A question or sentence? Engine is needed also for regular SPICE session. Yes, this is correct. And even in this case, once the connection is established, if I am correct, once the connection is established, the engine can go down. Of course, this is no good, but for the sake of connection itself, no problem. Any other question? In any case, ping me anytime on this channel, oVirt on OFTC, or on VDSM channel on Freenode. I'm here basically every time, anytime during the day. So, okay, I think there are no more questions. So, thanks everyone who attended. The slides will be available on the oVirt wiki. On the oVirt wiki, there is a page which describes the feature. On that page, features / serial console. On this page, you can find some information and a link to these slides. There is also a page, a work in progress page, which describes how to manually set up this guest serial console. And it contains also a few tips how to troubleshoot the guest serial console if something goes wrong for some reasons. It is a work in progress because I would like to make it up to date and add more and more information to troubleshoot as time goes by. So that's it. The recording of this deep dive will be available on YouTube in the following hours, I think. Thanks, everyone, and bye-bye.